Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. This is the final video in our series on time series analysis, specifically looking at exponential smoothing. Now we've already seen single exponential smoothing, which looks at data across time, typically flat data. We've looked at trending data with double exponential smoothing, but at the end of the last example, we had data which had a little bit of seasonality involved. We could see that about once a quarter the values we were seeing were dipping. So how can we make a good fit that works with data which is basically seasonal? Well, the answer to that is to use triple exponential smoothing. Now triple actually, it does what it says on the tin. We have single exponential smoothing, which is irregular smoothing. We then have double, which is single plus trending. And triple exponential smoothing is single plus trending plus seasonality. So it allows us to take all three of these factors into account as we fit the values to the data we're provided with. So let's have a look and see how we can adjust this model from double and go to triple exponential smoothing. Now the code we can look at in a moment. However, as already mentioned, you need to keep the predictive analysis library, the reference manual, handy. If we go here and we just scroll down a little bit to the predictive analysis functions for time series, we can see we have single, double and triple. Notice that the keyword we use for triple is triple smooth, and in fact we can get more details by clicking here. We can get details on how the triple exponential smoothing is calculated, and we can see information on which parameter names to use, which tables to use, and what the parameter values we can use within it are. And in fact, for single, double and triple, the signature file, the input and output structures are identical, so we don't need to make any changes there. But notice there are actually a couple of new parameters available with triple exponential smoothing. We have something called the gamma smoothing factor, and it's similar to the alpha and beta we already saw with single and double. The gamma factor basically is a smoothing constant that applies to the seasonality in our data. And also we have a new value called cycle, which basically allows us to identify what the cycle of seasonality is. For example, in the number of time periods. If it's a quarterly cycle, it might be every 4 periods. If it's a annual cycle, monthly cycle, it might be 12 periods, etc., etc. So we've got the cycle that we also can put in to help tune the way that we're working. Otherwise, it's pretty much the same as we've already seen. So we can go back to our code. So we need to activate the AFL schema, and then we need to change our call to make a new procedure. In this case, we're going to use triple smoothing, so we'll put a T at the end for triple, and we need to specify the keyword so that the AFL generates us a triple smoothing procedure. So we can now run that, and we've got our triple smooth procedure created. There's nothing needed to change on the input data or the output data. However, for the parameters, what we can do are add those two new parameters. So we had the gamma value. Let's create a new row for the gamma, and just to start with we'll set that to 0.1, so fairly conservative, looking at the history a pretty long time. And the other one is to look at the cycle, the seasonality cycle. So again here we can put in cycle, and cycle is an integer value. In fact, it's always good to go and check back. Gamma is a double, cycle is an integer value, so we need to make sure we put in the integer value. So a cycle of 1, in fact, let's try maybe quarterly, as we already saw the data. It looks like it's a quarterly fit. Okay, so now we've done that, let's just create these rows in our parameter table because they weren't already there. We didn't have them before. So that's gamma and cycle. However, we need to make sure we're using the correct schema. So let's set it to the PAL schema. Now let's create our gamma and cycle rows in the parameter table. Now we've done that, we can actually run it. So again, we simply just clear out the results from last time and run our triple exponential smoothing. Now let's have a look at the results view. If we refresh that, let's see how it works. and we see, yes, a much better fit. We can see there's some seasonality been built into this. Even so, it's still forecasting out into the future. And again, we can play with this and tune this as much as we want. Perhaps maybe we want to go 12 months out into the future, and let's maybe set the value for beta. For gamma, we haven't updated that yet. We're using the default. Let's maybe increase our value for gamma, which is the seasonality. Let's put that to 0.4 as against the 0.1 we had as by default. Let's just update those in the table. Let's truncate the results and run the analysis again. And this time when we refresh, we see maybe a slightly better fit. And again, you can continue to tune that as you go forward. So what we've seen now are 3 types of exponential smoothing for time series forecasting or for data fitting. We've seen single exponential smoothing, which is very straightforward and works well with data that's fairly constant over time. We've seen double exponential smoothing, which is much better suited to data that trends over time. And we've also seen triple exponential smoothing, which is very well suited to data which not only trends over time, but also has seasonality built into it. So that's the end of our little series on time series analysis.